graph the piecewise function. So we're going to graph a piecewise function. The word piecewise means this is pieces. How many pieces can you have? There's no limit. This one has 2 pieces. Notice it has 2 pieces, but it's one equation. This is like your y. Now, which piece do you use? Well, if your x is less than or equal to 3, use this piece. If your x is greater than 3, use this piece. So notice f of x can be written as y. And so we have use y equal x minus 2 for x is less than or equal to 3, and you use y equals negative x plus 8 for x is greater than 3. So what you do is you graph each line, but this part that says x less than or equal to 3 or x greater than 3, that tells you up to where to graph the line. This line, this one here, the first one, y equal x minus 2, says that I should graph the equation only up to x is less than or equal to 3. So this line would be going on, but we erased that part and it stopped here. This one is y equal negative x plus 8. But it says only keep that part where x is greater than 3. So I erase everything that came before 3. Now notice this one had an equal sign, and I stopped with a solid circle. I colored it in because of the equal sign. This one doesn't have an equal sign, so here at one of the endpoints where it starts, it's open. So if you don't have an equal sign, it's open, and if you have an equal sign, it's closed. Graph of the absolute value function. This is another very popular graph, the absolute value function. And notice it's a piecewise function. It says you're going to let the absolute value of x equal the x that was in there. Just copy it. If the x is greater than or equal to 0. And you're going to let the absolute value of x equal negative of what number you had in here if the x is less than 0. So again, each one of these is an equation. This would be your y. So you're going to let y equal x if x is greater than or equal to 0. And you're going to let it equal y equal negative x if x is less than 0. So you could draw this line and then remove this part, because this part, okay, this one here, I'm sorry, this one that's going up is y equal x. Now remove the lower part and just keep that part of the graph where x is greater than or equal to 0. These are x's greater than or equal to 0. So you just keep this part of the line, remove this part. This one, with a negative slope, it's coming down. This one, you're just going to keep all that part of the graph where x is less than 0. So you're going to keep this part of the graphic, because this is where x is less than 0. Here's another popular graph, the square root function. Remember, g of x is like y, so if you like to put a y there, that's fine. Right here, what you have to be careful with is that the radicand, that's the quantity under the square root, should be greater than or equal to 0, because you can't take the square root of a negative number. So you tell it this quantity has to be positive, which means greater than 0, or equal to 0. Because the square root of 0, there's no problem. So you solve, you move this 1 over by adding. So you have x greater than or equal to 1. In other words, the picture is going to start at 1 and move for x is greater than 1. Here are some points that you could plot. These are picked at random, but when I pick them, I have to pick x's that are greater than or equal to 1. These are very simple x's. You could have picked some other ones. And this is the curve you get for the square root function. Graphs in the vertical line test. We would like to know if a graph represents a function. And it's very simple. All you have to do is draw a vertical line through it. And if you draw a vertical line anywhere you want, and you always just hit one point, intersect one point of the graph, then that graph is a function. If you intersect more than one point of the graph with a vertical line, then that graph is not a function. Here's an example. Just imagine drawing a vertical line through here. Each time you draw a vertical line, no matter where you put it, it hits only one point of the graph. Therefore, this graph represents a function. Look at this one. If you draw a vertical line, you might hit a point right here, but I'm supposed to be able to hit one point everywhere. So if I move it somewhere else, I hit 2 points when I draw the vertical line, so it's disqualified. This does not represent a function.